In the previous video of Robomaster Tello Talent, it demonstrated the collision avoidance capability. I now would like to share with you the code and how to do that with block programming. I will first go through the program flow, then we'll go into the detail of each functions needed to complete the whole program, as you have seen in the demo video. In the video demo, I was using the DJI software called Tello EDU. This mobile software can run on either iOS or Android OS. In this tutorial, I am using the Android version to run on my Samsung tablet. So I will walk through first for the program. I assume that you know some of the minimum level of the setup of the variable. As you see on the left hand side there, that we can set up variable for each the value in here. Okay. All right, so we can go straight into it. So for the Tello AU software, it always begins with the first block called the tab to start. So everything, every other block you add in, it will be beneath that one. So when we run the program, we just hit the first block. That's why they call it tab to start, and hit that one, it will run the whole program. Okay. So in this program, as I show you like this, you can pause your video and then to work along with this video and create a program with this. For this Tello education, it's not going to export out one of the file. It did save the file inside the system, but not export out for the file so that you can import in. So the best way to share here is that you can look through the video and then follow each step we have here. Okay, so first of all, that we need to set up the sum of the variable. So we have a variable height. Basically, this one is that we want to set the Tello Talent drone fly at a certain height that we want to have. So if we want to fly any specific height, all of this one is in centimeter. Okay, so that you can specify this one high or low. It should be on your preference. Second is that the altitude. The altitude basically that it will measure that how far from the bottom of the drone to the ground at the bottom, beneath of the drone when it fly. Okay. Left turn. So this one just gives them an ID. So left turn we name it 0, and the right turn name is 1. So it gets binary. And we have the variable called the last turn, just so remember when it turned, the last time it turned is it was a left turn or it was a right turn. So initially we just say it the last turn was the left turn. That means it's the next time if the road it turned by itself, it will based on this one and say, okay, last time left turn, now we're going to do the right turn, and or vice versa. Okay, so it gives us option to make decision there. And next that is very important that we need to enable the TOF, that is type of the flight sensor, the module. So this module especially is only available on the Tello Talent drone. That is the little one on top of the body of the red cover of the Tello Talent drone. So it has a sensor on it that where you will also see all the LED, the matrix LED display. For some other drone, just like the Tello drone, the white body, it doesn't have this. So this program apply only for the Robomaster Tello Talent. And then initially we also set up one variable for the time of flight variable TOF equal to 0. So it did initially. And now is the time that we asked the drone to take off. Okay. Every command that we send to the drone is not going to work until that the drone is going to take off. So it when it up in the air, then it will stack take all of those commands in and it will execute. But if it's on the floor, then it won't do anything. Okay. So first thing we need to do is have is take off. So when it take off, we will have is the update the time of flight value to the sensor. So how the sensor that we set that value to the sensor. So the forward TOF distance sensor that is on the module, it look out. Depend on what distance at that time, it will assign for the TOF value. Okay. And next step that we want to do is that we're going to set the speed. So when we set the speed, that basically that we want to say, okay, we want to set the speed because that depend on what the distance that the sensor is seeing. If it's seated very far, that no obstacle in front, it's going to hit something, then it automatically set up the speed a little bit faster. But if it sees something in front of it, close up front, then the speed going to be slower. Okay, so it dynamically adjusts for it, even though that we have some limit for them, in case we don't want it to go too fast for some a particular environment we want it to run. Okay, and then we have another function. So after we set up the speed, okay, we're going to tell it to go into the safe height. It basically that is where we define that because when it take off, by default it will take off somewhere around 50 centimeter to 1 meter. So in that area, depend on the location where you have it at. So it will be like 50 centimeter of the level beneath of the road. Okay, between that 50 to 1 meter. So we just tell them to fly to the safe height. That's where that we use the value of the height is. So we initially we say okay, we put 120 centimeter. I mean when we call this function, the drone automatically try to adjust the height to the 120 centimeter above the ground. Okay. And then for this demo, we will have it to fly for the demo. It's for 5 times. That means it can go back and forth, and then after 5 times, then it will land. Okay. So when it land, it could basically that we want to check because sometimes it flies initially high. In the case that we have here is 120 centimeter. So we want it before it land. We don't sometimes that we just give it some good safety, like not drop from like 10 feet something like that and all the way very fast to the floor. So the road itself, it will automatically try to slow down, but however it's sometimes it's still fast. So the best is that we tell that just okay, if it's too high currently, go ahead and just go down first at some level close to the ground and then safely landed, and that will be the end of the program. Okay. Now, as you can see in the block programming is good thing that if something is inside the loop, for example, for the repeat 5 times, is big, we can have it basically minimize it, so you can have some space. So in this case, let me show you that what inside. Okay, so you just touch it and it will expand it by itself. So that inside the repeat, it basically have a 3 more command in there. That one command it will call upon a function. It call it checks okay to fly. Basically, this is one of the function for the collision avoidance. So before it try to fly, it will just verify in front of it, is it clear, no obstacle in front, and if say okay, then we go. If not, then that function will help it to take care of the collision avoidance. Then if it's clear, we allow it to move forward 50 centimeter, and then wait a little bit, basically wait a bit just to give the system inside, when it have a movement, it just smoothly movement, and then we go around and check one more time, and then keep doing like this for 5 times. Okay. For this particular the block programming, there are certain of the command available for us to use. So all of this one it used based on that. For more advanced programming, there will be a lot more option to do, but that will be different. So we just based on this block programming, that where that this software allow us to use some available block command in here. Okay. All right. So that's all that could be the full program. But now we just deep dive a little bit. So in this program, there's 3 more function that we going to make for it. First of all, I call it the set to speed, fly to the safe height, and then check okay to fly. Okay. So we can go one by one. For the set speed, it be the function below here. We can go in the sequence in order. Yeah. Okay. So the set the speed. Basically, the set speed is that, as I mentioned before, it could be a dynamic setting for the speed of the drone. If they have plenty of distance in front of the drone, then it will calculate and give the drone at the highest speed that it can go. But in here, actually, we did have some limit for that, upper limit. We don't want it go too fast, even they have plenty of space in front. That will be up to us to set up in here. All right. So in this case, that you can see the set to speed function in the middle here. We allow the system to check up to 60 times. The reason for that is that first time we power on the drone, it may take some time when we enable the module. So we allow it to make a measurement until it gets some measurement. As soon as it gets some measurement, sometimes it not even require go up that many times. So we just set it some number of time to allow, because each side go around like this is very fast too. So just put it 60 times, but maybe it gets only like 4 or 5 times that is done, and then it will be out. So you can see in here maybe 60 times, but we tell that the update the TOF value to the value that when the sensor measurement get to the forward TOF. That means the sensor look forward from the drone. Okay. and distance is determined is in centimeter. So as soon as the TOF measurement is greater than 10, normally if the sensor is not working, it either will be 0, okay, stay 0, or any number is very kind of negative number or 0. So as soon as the value is just above 10, that means it confirms that the drone see some space in front of it, not like something blocked in front of it from beginning. So if you set the drone right against the wall from beginning, that's what it's going to see. Okay, so it will do something. All right. So when it see is more than 10 centimeter, that means that the drone is in the good condition to ready to go to the next step. Okay, so the measurement is above 10 centimeter, then we go to the next step. So next step is that is we'll try to set the speed. As you can see, it calculate here. So depend on the distance. If distance so big or something, it get divided by 3. So it just reduce the number. But however, if because if the distance is so big, then the value of speed is will be very high, and at a certain point that we don't want to have the drone to fly so fast, so we can put limit here. In particular, the very comfort speed that we have, like if run indoor right now, just set at 30. Okay, so it never go higher than that. You can change this value to any the number that you want, but 30 will be kind of a good speed to control for indoor. And then after this one, since we get the variable of speed to the number that we want to have there, and now we just program into the drone. So the command speed, the percent, it could be 30% of total maximum speed that for the drone, it could be set on that command. Okay, so that function is done. All right, the next function is that for the height. Okay, for the height, that means that when we tell it the drone take off, after take off, we want it go into the some height that we believe that is good for us. For example, that height is not straight to the face for some person, and it's not very high, it hit the ceiling, and not too low. Okay, so you can choose some height that is very comfortable for the demo, and under total control and safe for it. So in this case, as you can see, we set the altitude variable to the value of the sensor. What that means in this command right here, the sensor it make a measurement very often inside it built in the command in the internal program, so it make the measurement all the time. So in particular this time we just wrap the data, so we set the altitude to particular value that at that moment for the sensor, and then we check what the kind of the value is at. So if the altitude, if it's higher than the height that we just tell, for example in here is 120 centimeter. If it's too high, and then okay, all right, we want it to go down. So that's what the command said, down. And the altitude is that whatever altitude there, we want it to subtract the height. That means it subtract with the delta. So it means it go down by a delta between them. So it could settle at the height that we want. But if the drone is below the height that we want it to be, and then we could tell that the drone fly up, okay, and it will end up with the altitude 120 centimeter we want. All right, so that's the two function. And lastly, the main function that in the demo that we want to know is that is the collision avoidance. So as you know that when we enable the TOF measurement module, sensor module, then the sensor is going to make a measurement of the distance very frequently all the time. So that's what this function is. This function call very soon, often, and the sensor and the drone will react to any obstacle very quickly, so it will avoid to collide to anything very quick. But if you don't call this one very often, then that's the problem. That's why this function will be used to call before it make a move. So just make sure everything okay before it make a move. All right. So in this function here, at first that we update, we want to know what the distance in front of the drone to any object out there. So that with that one we update the TOF value to that particular time, that instant of the time, what the value the distance to any object out there, and then we check to see if that object is within the range. So the TOF greater than 1, that means the sensor is running. If it's 0, it's not good. It has to be non-zero. And then we want to make sure if it's greater than 1, but and it's below some value. So in here we say it's below 90 centimeter. So we give us some safety limit. So when it's flying, if you see the wall or any object before that in front of it is 90 centimeter, it kind of safe space there to react, because sometimes when it move, it fly, it still have some momentum. So with the 90 centimeter, it gives us enough time to react. So basically, it will stop way before that, and then it safely do something to handle the collision avoidance. Okay. Well, in here I put some thin bonus here that to show you how to use the display as well, and the LED. So on the module LED and the matrix module on top of the body of the Robomaster Tello Talent drone, we will be able to program it to the way, to any color that we prefer. And not only that, for the matrix, it can display some the pattern that we can create. Okay, so first of all, that if the drone it seeing something in front of it less than 90 centimeter, that means it's time to stop. That's why we turn the LED to red, so it indicates that it recognizes something. So if we observe the drone, we can see the red color. No, yeah, the drone is seen something and it start to make decision. And now, if we look at into the display, that means that if it make a right turn, we can see that the arrow point to our left. If it make the left turn, we can see the arrow point to the right. As you can see from the condition, if it was the left turn from the last time, then it going to rotate right 180 degree. Otherwise, it will rotate left 180 degree, just like a U-turn. Now, if without any obstacle being detected in front of the drone, then it go into display the forward arrow, and then it will turn on the LED to the green light, so it say it's okay. Now, before doing that, it will update the TOF value based on the latest distance it measure from the drone to the any object out there. it also recalculate the speed based on that measurement, and then to report back before this function return to the main program. After this function return, we now can go back to the main program where it's make a call. So basically, it gives the green light that it will be able to continue to move, so that where the drone will execute command of forward. In here we set the 50 centimeter. Remember that this value normally will be smaller than the distance it check for the object in front of the drone. And after it move, it just give a short time to wait, and then it will come back for the next step. So as long as in the loop we set to any number of the loop. For this case, we set to 5. In some of demo I saw there, it was 3 times, just for a quick demo. But you can set to any number, and then it will execute and then finish. And once it's finished, it go into prepare to land. Because that we don't want to have the drone that land from any high distance it may be at that time. So we just ask the drone to check if it's too high than the 50 centimeter, then it just need to slowly move down at the height of the 50 centimeter from the ground. Then from there it will take the command to land. So now it's just like we have a soft landing, and then after that the program is finished and it is done. Let's now have a quick review the video. That's great. If you have any question, please put on the comment, and I can help to answer that. Yeah, thank you very much for watching, and you can subscribe my channel for the next video.